rational numbers. Okay, so let us consider two numbers a and b. Okay, let us consider a and b both are, say, positive integers. Okay, so when we divide a by b, we see two cases. Okay, first case 1, if a is multiple of b. See, if I can write this as a is equal to mb or m is equal to a by b. If I say that a is a multiple of b, I get some answer m. Now m is a natural number. It can be a natural number, it can be an integer also. Okay, this is the first case. Second case, if a is not a multiple of b. Okay, so if I divide a by b, I don't get an integer. Okay, so there are two cases where a can be a multiple of b and a is not a multiple of b. In both the cases, we get a different set of numbers which we call as rational numbers. Okay, in both the cases. Suppose if I give you an example, if a is a multiple of b, say if I say 10 divided by 5, we know that 10 is divisible with 5, 10 is a multiple of 5. What do we get? 2. So we get an integer or we get an actual number. Okay, so here we can say 2 is also a rational number. Okay, and case 2, if a is not a multiple of b, suppose if I give an example 11 divided by 7. So 11 is not divisible by 7, it is not completely divisible by 7, but we can write it in the form of 11 by 7 where 11 is not a multiple of 7. So in this case also we call these numbers as rational numbers. Okay. So now we can define the rational number as a number which can be represented in the form p by q. Okay, where q is not equal to 0. Say if I write an example 1 by 2. So it is in the form of p by q where you have p as the numerator and q as 2 as the denominator, right? And here the denominator, that is q, is not equal to 0. Okay, so this is how we define a rational number, a number which can be represented in the form of p by q where q is not equal to 0. So if we take some other examples, say if I can take 5 by 8, okay, or I can take minus 11 by 7, even the negative numbers also. So we can write in the form of p by q where q is not equal to 0. So even 0 also is a rational number. Okay, why? Because we can write 0 also in the form of p by q, that is 0 by 1. So 0 can be written as 0 by 1. So 0 also becomes a rational number. Okay, now we'll study about positive rational number. Okay, and negative rational numbers. So how do we write positive and negative rational numbers? We should know. Okay, now the positive rational numbers we know rational numbers are written in the form of p by q. So positive rational numbers are the numbers where both the numerator and denominator, okay, are either both are positive or both are negative. In both the cases, we can say that the rational number is a positive rational number. Say example, if I write, if both are positive, if I write positive 1 by positive 2, so it becomes 1 by 2, positive rational number. If I say minus 1 by minus 2, if both the p and q both are negative, also it is positive rational number. Okay, so in this case you see both are positive, we get the rational number which is positive rational number. When both the P and Q are negative also, we get positive rational number. Okay. But in case of negative rational number, either P or Q is negative. Okay. Say example, if I say minus 5 by 8. So here P is negative, P is negative. So this is a negative rational number. Or you can say 11 by minus 7. So here Q is negative. So this rational number is also considered as a negative rational number. So either P or either Q is negative, then we can say the rational number is a negative rational number. So the next topic we will study is about the standard form of rational number. So how do we write a rational number in the standard form? So I have told you already, P by Q if I write, or minus P by Q if I write, or P by minus Q if I write, or minus P by minus Q. If I write these four rational numbers in this way, both are considered as, all are considered as rational numbers. Okay. So now what do I do? P by Q, since both are positive, I can write as P by Q. Minus P by Q, here numerator is negative, we don't do any changes. If I write P by minus Q and I multiply with minus both in the numerator as well as in the denominator. So what do I get? I get here minus P, P becomes minus and Q becomes minus into minus plus. Okay. And in the last case, minus P by minus Q, I will multiply with minus on numerator as well as in the denominator. So what do I get here? Minus into minus plus P and minus into minus plus Q. So there is no need of writing plus, we will ultimately get P by Q. So you see that in all the four cases, what have I done? I have made the denominator positive. Here Q is positive, here Q is positive. It was already positive, we didn't do any changes. But here Q was negative, so I made it positive by multiplying with minus in both numerator and denominator. Here also both numerator and denominator were negative, so I made it positive by multiplying with minus, right? So I get plus P by plus Q. So in all these four situations, we get standard form of rational numbers. Okay. So in these four situations, what do we see? Q is positive, right? Or it is made positive. So I have made it positive. And also one more thing you see is the common factor. The common factor between P and Q is 1. That means they are co-prime numbers. Okay. So there is nothing common between P and Q. What is common? Only 1. So such numbers are called as co-prime numbers. So if I give you an example, say 3 by 5. Now 3 is positive, 5 is positive. And what is the common factor between 3 and 5? The common factor is only 1. There is nothing else which is common between 3 and 5. There is no common factor between 3 and 5 other than 1. So 3 and 5 are co-prime numbers. So the standard form of 3 by 5 is 3 by 5 itself. Suppose if I give you one more example, if I say 8 by 16. Now there is a common factor possible between 8 and 16 other than 1. Okay. So what are the factors of 8? 2, 1, 4, 8. Right? Factors of 16 also 1, 2, 4, 8, 16. Right? So these are the factors. So what are the factors between 8 and 16 possible? More than 1, right? 2 is also a factor for 8 and 16. 4 is also a factor of 8 and 16. 8 is also a factor of 8 and 16. So here this is not the standard form of rational number. We have to convert it into the standard form. That means we have to convert into the lowest form. Okay. So if I divide with 2, what do I get? 4 by 8. Again it is divisible with 4. We get 1 by 2. Now 1 by 2. So we have arrived at the number 1 by 2. Now 1 by 2 is a standard form of 8 by 16. Why? Because there is nothing common factor between 1 and 2 other than 1. Okay. And both are positive. Here both were positive, so there was no need to worry. But if you see between 1 and 2, the common factor between 1 and 2 is only 1. So 1 and 2 becomes the standard form of 8 by 16. Okay, so we can say that the rational numbers are the numbers which can be represented as P by Q, where Q is not equal to 0 and Q is made positive or it is already positive. Okay, and the common factor between P and Q is only 1. That means they are co-prime numbers. Alright, so such rational numbers will be called as standard form of numbers. Okay, or we can also use the term lowest form. Okay, sometimes in your book questions will be asked as write the lowest form of the following rational number. So if I give you again one example, I will give you maybe 1 by minus 2. Now here if you see the Q is negative, right? The denominator is negative. So the lowest form of this I can write it as minus 1 by 2. Okay, so we don't write the lowest form or the standard form with Q as negative. We have to make Q as positive. Okay, one more example, if I say take 5 by 18, 5 by minus 5 by 18. So here also there is nothing common factor between 5 and 18 other than 1. Here Q is positive, so no need to do any changes, and numerator is negative, that's fine. So here we have the standard form as minus 5 by 18 itself. Okay, there is nothing common between them. We can't reduce it to lower term. Okay, when we say lowest form, that means we can reduce the rational number into the lowest form if possible. If it is not possible, that number itself becomes the lowest form of that number or the standard form of that number. Okay. Also in one more case you can see, if I say both are negative. So here both are negative becomes a positive, right? If both numerators and denominators are negative, in the standard form we can write both positive. Now we can divide it with 5 because they have a common factor, that is 5. So we get the answer 1 by 5. So plus 1 by 5 is the standard form of 5 by 10, minus 5 by 10. Okay, so two things you have to note by the end of this topic is, the first note you have to make a note of it is that every natural number is a rational number, but vice versa, means the other way around is not always true. For example, if I say 2 is a natural number, right, and it is also a rational number. How this is a rational number? Because 2 can be written as 2 by 1. It can be written in the form of P by Q. Okay, but other way around is not possible, right? If I say 1 by 2, it is a rational number. But is this a natural number? No, because it is in the form of fraction. It is in the form of P by Q. The number in the P by Q is a rational number, but it cannot be a natural number. Okay, so every natural number, any natural number if you write 2 or 3 or 4 or 10 or 100, all these numbers are natural numbers. They can also be written as P by Q by writing by 1 by 1. So we can write in the form of P by Q and they are also rational numbers. Okay, but the other way around, we can't write a rational number. We can't say all the rational numbers can be natural number. Okay, like 3 by 5 is a rational number, but it is not a natural number. If I say 121 by 4, this is also a rational number, but this is not a natural number. Okay, so second note is every whole number is a rational number, but vice versa is not possible. Now every whole number is a rational number, right? Every whole number like 0 is a whole number, also rational number. How this becomes a rational number? Because 0 can be written as P by Q. 0 can be written as 0 by 1. So even whole number along with 0, 0, 1, 2, 3, all the numbers are rational numbers. But all rational numbers cannot be whole numbers. So if I say minus 3 is a rational number, I can write it as a rational number because minus 3 by 1 is a rational number. But is minus 3 by 1 a whole number? No, it is a negative integer. It is not a whole number. So minus 3 we cannot say it is a whole number, but it is a rational number. Okay. So these are the two notes which you have to remember for your exam point of view. So now we'll take up the example 1.5 in the NIOS textbook, which says that which of the following numbers are rational numbers and which are not. So they've given you again some set of numbers where you have to identify which are rational numbers or which are not rational numbers. So basically all the numbers, any number you write is a rational number. Okay. So here you see minus 2 is a rational number. It can be written in the form of minus 2 by 1. 5 by 3 is in the form of p by q. Right. This is in the form of p by q. Even minus 17 can be written as minus 17 by 1 in the form of p by q. 15 by 7 is also in the form of p by q. 18 by 5 is also in the form of p by q. And minus 7 by 6 also in the form of p by q. Right. That means all are rational numbers. Here all the numbers given are the rational numbers. Okay. It can be written in the form of p by q. Now example 1.6 asking write the following rational numbers in the lowest form. So we have to write these rational numbers in the standard form or the lowest form. Okay. So first we have to see here the denominator is already positive. Okay. So we don't have to do any changes here. Numerator is negative. So now we see the common factor. So both are even numbers. There surely 2 will be a common factor. So you can divide with 2 and you can get the lower number, right? So 24 divided by 2 is 12. We will write the minus as well. And 192 divided by 2 will be 96. Okay. Still we can divide with 2, both the numerator and denominator. We get minus 6. 96 divided by 2 is 48. Further we can divide with 2. We get minus 3 by 24. Again both are divisible by 3. We get minus 1 by 8. So you see we reach minus 1 by 8. After that we cannot reduce. We can't get the lowest form because the common factor between 1 and 8 is 1 only. Okay. They are co-prime numbers. There is nothing common factor other than 1 between them. So the standard form of minus 24 by 192 is minus 1 by 8. Okay. See the next question now. 12 by 168. So 12 divided by 2 we can divide by 2 because both are even numbers. So we get 6 by 84. Okay. Again you can divide with 2. We get 3 by 42. Okay. Again it is divisible by 3. We get 1 by 14. Okay. So this is the standard form of 12 by 168. After 1 by 14 there is nothing common between them other than 1. So we cannot go further from here. Okay. Here if you see the last question, minus 21 by 49. Both are divisible with 7. If you remember the 7 table. I hope you remember 7 table. So minus 21 divided by 7 is 3. So we have to retain this minus sign. 49 divided by 7 is 7. So this is the standard form of minus 21 by 49. See there is nothing common between 3 and 7. They are co-prime numbers. Okay. So this is the way we find the standard form or the lowest form of the rational numbers.